Hello everyone. In this video, we are going to discuss about this third problem, that is exit door from division 4 from Codechef starters tutorial. Okay. So in this problem, they told that there are n number of people sitting in the same row in a movie theater, and each person is having a priority as well, and that priority ranges from 1 to n. Okay. So after reading the description, you will be able to understand that end of the day, they want that how many number of people will be disturbed by each and every person if they choose the minimum number of people will be disturbed. Okay, so I will convert in a simple way as well for you now. Okay, so let's take one example here, and input wise also we are clear that they will give n, so where it specifies the number of people that we are going to have, and then they will give an array. So I told right, so each and every person is going to be associated with a priority. So where this array, where this A of I will represent the priority of ith person. You got the point? Okay. So let's take a test case or an example where n is equals to 5, and then array will be like this: 1, 5, 3, 2, and then 1. Oh, sorry, 4. It will be. Okay. So in this, what we need, there are few things as well. Okay, so after completion of the cinema or the movie, the person who is having a top priority need to be leave the theater first. So either that person can choose the left or right, but they need to choose the direction in which direction they need to disturb the minimum number of people. Okay, so in this example, if we consider who is having the top priority, definitely the person who is having highest one. This person, right? So the person who's sat on this first index, right? So this person need to leave this theater first. So they need to choose either left or right. If he chooses the right, how many people will be disturbed? The person who sat at second index, third index, and fourth index, right? So total 3 people will be disturbed. So if this person chooses the left direction, how many people will be disturbed? The person who is uh, sat at this zeroth index, that is 1. So, right? So this person need to choose the direction in which he need to disturb the minimum number of people, right? So if I choose this, how many people need to be disturbed? 3. If I choose left, how many people will be disturbed? 1. So which one we will choose? Obviously the left one, right? So the person who is having 5 priority will choose left direction and he will disturb only 1, right? So likewise, same thing will happen for the next other priority people as well. So as of now, 5 we are done, right? So 5% left now. So now we are left with this 4, 4 people. So now who is having a top priority in this modified array or in this updated array? This 4, right? So in this 4, if this person wanna move in right direction, how many people will be disturbed? No one will be disturbed. If this person who to be move in a left direction, how many people will be disturbed? 3 people, right? So which one I will choose for this? Only right direction, which will give 0 people will be disturbed, right? So next, after this person also left, how many people we are left with? 1, 3, and 2. So who is having a top priority now? This 3, right? So if this person wanna move in left or right, this person is going to disturb only 1, right? So for 3 causes disturbance for 1 people at minimum. And after removal of this 3 as well, we left with 1 and 2, right? So if this who is having top priority? 2, right? If this person move in the left, how many people will be disturbed? 1 person. If this person move in the right direction, how many people will be disturbed? 0 persons, right? Because on right direction, no one is there for me. So 0. So next, we are left with 1 only, right? So if this person wanna move in left or right, how many people will be disturbed? There are no person except this person, right? So if this wanna move in left or right, 0 people will be disturbed. So now I want the total number of disturbed people because of each and every priority person. That is 2. So this is what they're asking. So pen and paper wise, everyone is clear, right? So now we need to find a logic that how we would solve this problem. Logic is simple. The way we iterated on this value, right? The way we thought, the way we processed in this entire thing, the same thing will be converted in a coding manner. The simple thing is how we need to find the left number of people and right number of people. That is what, right? So if you go with this example in a clear-cut manner, we are able to see. First one we have, and then five, and then three, two, and then four. This is what we have, right? So if you take a look on this, what I need? I need minimum number of people present in a left direction and as well as a right direction. That is what I require, right? So now the point is how I can find out how many people present in right direction and how many people present in the left direction. Let's go with the indices once, guys. Okay. So how am I able to check the how am I able to identify that the person who is having a top priority here? I already know that 1 to n is the range given from Indra. So who is having the top priority? Definitely n, right? So here who is having a top priority? Because the size of the array is 5 only. So definitely 5. And I'm pretty sure that there is unique priority given from. So the person who is having a 5 priority and he is the one and only person having that 5 priority and there is no duplicate priority given for anyone. Okay. So I need to find the person who is having top priority sat at which position, right? So if I find the position of the top priority person, do you think that it will be helpful for me to identify how many people are present in left and right? Yes, of course. If you take a look on this, the top priority person stays at which position? At index of 1, right? So how many people are left present in left side? Only 1, right? So if you see here, if I consider temporarily try to take uh, this third person, the 3 one, okay? So at which index this person is present? At index 2, right? So how many people are present in left side of this person? 2 people, right? 0 and 1, right? If you consider this 3 person, the third index one as well. The index is 3. How many people are present in the left side? 3 people exactly. As the array index starts from 0, it would be helpful for me. The person who sat at the 3 index on left of him, 3 people will be present. So index is directly giving the answer, right? Who are present in the left direction? Yes, of course. So let's come to the 5, the person who is having the top priority here. Yes. So here, can I say that the index or the position at which the person or highest priority person stays or lies at, that index is directly giving the left count? Yes, of course. We checked with other things as well, right? Other elements as well, other people as well. So now the point is how we can find the right, how many people present in the right direction as well. Okay. So how we can find that? Okay. So we need to find this span. How many people present in this span, right? So answer this question. Do I know how many people entirely present in this array? Yes, of course, that will be size of the array, right? Yes, of course. And let me give this one as well. How many people are present in the left direction? I know directly because of this I, right? So how many people are present in this left direction? This I will give, right? So if you consider this visualization part here in this line diagrams, I know this entire number of elements I have, and I know this left side how many I have, and here I'm checking for this span, the red span here. mentioned. This one, right? Yes. So I don't know this, but I know entire and I know left. And here I'm not considering this one, right? Where this person currently lying. We are not considering this. So we need apart from this. So I know left and I know this. So don't you think that if we remove this from this entire one, if we remove this part, we are able to get this red span as well. So what is this? This is known as array size. In this array size, what I need to remove? I need to remove this left of this number and then the current one, that is, it will take one only, right? So minus I plus 1. So from this entire one, what I have removed? This I plus 1. So then I'm able to get this remaining part, right? So this is how I'm able to get the people who are present, number of people who are present in a right direction, right? So now I'm able to find. So what I need? I need minimum number of people will be disturbed. So from left side, how many people? I. From right side, this formula. So I need minimum number from these two. Got the point? Yes. So after this person moved from here, how many people we are left with? We are left with this four people. So who is going to have a highest priority here? This person, right? So I need index of this person, right? So left side, how many people? What is the formula for that? I only. I is nothing but what? The position where the top person, top priority person is lies. So the position is 3. And how many people are left? Left side present in 3 people only. And in right side, what is the formula? Array size. It's not about n always, guys. The first time we can say that n minus I plus 1 because we have n number of people as well there. But when it comes to second modifications or updations, when it comes to second person, other people who are having next priorities, for them, the previous person left, right? The fifth person left. So we are remains with 4 people now. So that's why array sizes changes. That's why I mentioned array size. So it's dynamically changes. Okay. So now the size is 4 and then left side how many? 3 and then plus 1, right? Here. How many people left in this right direction? 0. So pen and paper wise we are clear and we also got the logic. I hope now we are able to write the code as well. So try to remember one thing that whenever we got the index of the top priority person, we need to check the index and the index itself give the left number of people we have and then by using that index only we need to find the right number of people, right side people. Okay. So after getting the minimum value, we need to get that minimum and then what we need to do? We need to remove that person as well. Okay. So how we are able to know that? We already know the top priority person. We already know the priorities given from 1 to n. And there is no duplicate as well, right? So don't you think that if I try to iterate from the n to 1, if I try to get index of n first and try to get left and right and then find the minimum and then n minus 1. Try to find the left and right and then minimum. Don't forget to remove the n person. Here also n minus 1%. Okay. So if we go in this manner, the time complexity will be what? We are iterating on array, right? On the array, we are iterating. So what is the time complexity for that? On iterating on it, it will take n. And then in that what we are doing? After calculating left and right, and then what? We are removing it. And again for removing, it might take at max n only. So can I say 2n? So we go as order of n. So space wise, Am I using any other extra space apart from this array? No. So in for this array also, order of n I will get. There will be variables, but it is constant. So this is about time complexity and space complexity of this approach. And all the best.